Good day, everybody. We are still on electrostatics, and in this session, we are going to be talking about motion, right? We'll be talking about motion of an electron in a uniform field. So, we are going to talk about motion of an electron in a uniform field. So, we should understand that when there is an electric field, right, and an electron is on that field, what will happen is that the field will create a force, right, given by QE. Is it not? Now that force will cause the electron to accelerate. Is it not? Yes, to accelerate according to Newton's second law of motion, right? So that is F is equal to ma. So we cannot equate both of them, right? And say QE is equal to ma, and therefore A will now be equal to QE over m. This A here is called the acceleration. Q is the charge, E is the electric field intensity. Electric field intensity, and m is the mass of the electron. So if we know this, depending on how the question is, we can solve it. Let's take a question here. This is example 2.5. Listen very carefully. Example 2.5. It says that an electron is projected into a uniform electric field of intensity 5000 Newton, right? The electron direction of the electric field is vertically upward, right? The initial velocity of the electron is 10 raised to power 7 meter per second at an angle 30 degrees above the horizontal. Question 1 says find the maximum distance the electrons rises vertically above the elevation. And number 2 says after what horizontal distance does the electron return to the ground? In this case, we must understand that they gave us electric field intensity E here, right, to be equal to 5,000 Newton. Please, you can go play back the video and rewrite the question. With time, I will start displaying question on my screen. We were given initial velocity u to be equal to 10 raised to power 7 meter per second. We were given theta, right? Theta was given to be 30 degrees, and I think that's all the information we have here. So we are asked to find the maximum distance that the electron rises above the ground. The maximum distance that the electron rises above the ground. First, to do this, we must understand, right? We must understand that we start with the logic. First of all, what is distance? How do we do this? This is looking like a kinematics problem, but wait. To get the distance, we use S is equal to, right, UT plus half AT square, right? And the maximum distance will occur, this maximum distance will occur when what? When what? The time to get to maximum height. So the maximum distance will occur at the time it takes to get to maximum height above the ground, right? Yes. So first of all, how do we calculate for the time it takes to get above the maximum height? Remember that at maximum height, right? Final velocity v is equal to 0. So that is u is equal to, remember that v is equals to u plus a t, right? So in this case now, what will happen? Take this to the negative side, right? This is 0 because we say at maximum height, final velocity is equal to 0. So this becomes minus u is equal to at. So a is equal to minus u over the time. Sorry, we are not looking for a, we are looking for t, so that we can substitute our t here. So from here, t is equal to minus u over a. Are we together? Yes, but the question we ask ourselves, so let me write it somewhere. T is equal to minus u over a. Now the question we ask ourselves is that, what is our a here? What is our a? We'll bring this back later. What's our a? Recall that f, right, is equal to QE, right? And f is equal to MA. If we equate both of them, that means that QE is equal to MA. That means that A is equal to what? A is equal to QE over M. So if we substitute to T here, T will now be equal to minus, right, U over QE over M. Are we together now? But listen very carefully. This our U now. Now this U here is projected vertically at an angle of what? 30 degrees. So we must resolve it to the vertical axis because it was not directly vertical. It was 30-degree inclined, right? Yes, 30-degree inclined to the horizontal. But the original purpose, because maximum height is along the vertical axis, so we must resolve to the vertical. And we use the formula. Remember that vectors, when bringing vectors to the vertical, you multiply by sine theta, right? So that means that u y is equals to u sine theta. So we substitute here u sine theta. So that becomes t is equals to minus u sine theta, right? Because what we are using here is uy over QE over n. If we simplify this further, this becomes minus um sine theta all over QE. M is the mass of the electron, U is the initial velocity. So our T is minus sine theta all over QE. Are we together now? Alright, so if we know this very carefully, we can thereby go to the equation. So let me write it out here, that T is equal to minus u m sine theta all over QE. So our T will now be equal, right, to minus u sine theta, right, over QE over m, which is same thing as minus m u sine theta all over q e. Are you together now? So what we do is that we substitute to the equation of motion. We now have s to be equal to ut plus 1 over 2at square. And we already know that our acceleration a is equal to what? QE all over all over m rest. Yes, from we know how this came about, that F is equals to QE, the same F is equals to MA, right? So when we make a subject of formula, A is equals to QE over M. So if this is true, substituting into these parameters, our U is U sine theta. We already know that, right? So that becomes U sine 30. Sorry, let's just keep it simple first before substituting. Let's make it theta. So that is U sine theta, right? Our t here has been gotten as this guy, so that's times minus U sine theta, minus um sine theta over QE. Is it not? Yes. And if that is true, is bracket close? I'm getting it now. And if this is true, plus what is our acceleration? Plus 1 over 2. What is our acceleration? Our acceleration is Q E all over M, right? Yes, times multiply by what? Multiply by minus, right? MU sine theta all over QE all squared. Are we there now? Now let's simplify this. Although you can substitute your values and have your answer, but let's simplify it further. Square of a minus is plus, right? Because minus times minus is plus. True or false? True. But let's start from here. In this place right now, this is u sine theta. Also, this is u sine theta. So what we'll be having is u square, right? Sine square theta. And this m is left out. So that becomes u square. Let's bring the m out. Mu square sine, because there were two sine theta, sine square theta all over QE, right? Plus we have in here QE. Now you see this sign, this minus, it will come out. So that will be minus times plus is minus. So the minus will come out, that will be minus, right? Yes, minus 1 all over 2. Are you getting it now? QE. No, sorry. I told you guys that this minus square will be plus, is it not? Yeah, so that'll be plus here. So there's no need of the minus, there'll be no minus here again, so it's just plus over m times, now when we put in the square to everything, here will be m square, right? The minus will be plus u square sine square theta all over q e square. True or false? Now we can see opposite stuff that can cancel out here. Thank you, Jesus. QE. When this cancel each other, what will be left here, since this is square, will just be QE. when this cancel out, what will be left here will just be m, right? So we can rewrite this equation. We can rewrite the whole equation in here as something like s to be equal. Just give me a piece of time. No, learning take time. It's very important we submit to the time that learnings take, right? So in here we'll have our x, right, to be equal to mu square sine square theta all over q e, right? Already know that this place is minus. Yes, this side is already minus. If we missed, we not, it was a mistake. There is already minus here. You already know. Check back your notes. So in here will be 1 over 2, right? What will be left here now? No QE cancel QE. So we just left with 1. So there will be nothing here. That 1 over 2 bracket U bracket, sorry, M, the 1 M will be remaining, right? U square sine square theta all over QE. So this is our final value. We can just substitute here. I'll have an answer. But if you like to resimplify, you can simplify further to say S is equal to, what is common here? U square sine theta square over QE. U square sine theta square over QE. So we factor it out. That becomes U square sine square theta over QE, right? Yes. So that is mu square sine theta over QE. Same thing here. So what will be left here? Minus, right? Something like minus 1. And what will be left here? 1 over 2. And if we evaluate this, minus 1 plus 1 over 2 is same thing as minus 1 over 2, right? Times mu square sine square theta over QE. So when we have this right now, all we just need to do is to substitute the values that have been given to us. Are you getting it now? Yes, we just substitute the values that have been given to us. So we can now say here that in here that S is equals to minus 1 over 2, right? In the brackets of what is M. So in here, M is the mass of the electron, and the value for the mass of the electron is 9, right? 0.1011 approximately times 10 raised to power minus 31, right? Times what is U? U is the initial velocity given, so that is 10 square, right? So that is 10, that's bracket 10 raised to power 7 whole square times sine square 30. You know how to press this in your calculator now. That is bracket sine 30 square. Should be all over, right? The charge of an electron, that's 1.6 times 10 raised to power minus 19 times the electric field intensity, that is 5,000. So when you evaluate this in your calculator, when you evaluate everything here in your calculator, you will have an answer of 1 cm. So when you do this, we have an answer like minus 0.0142 meter, or multiply by 100, that is 1 point, right? 1.42 centimeter. So still minus, sorry. So I know some of you will ask, is this minus necessary? So we can ignore the minus, right? And say distance is equal to 1.42. The minus might mean that the electric field is going in the opposite direction where the electron is traveling to. Are you getting it? Yes, so that doesn't matter. Now, the question B says, after what horizontal distance? So that's B now. After what horizontal distance does the electron hit the ground? Hit its elevation. So we are calculating for horizontal distance. Very easy. Remember, for projectile, horizontal distance, right, is given. It's also called range. Horizontal distance or range, arrow, is given as u, right, cos theta times the total time. And this total time is equal to 2 of the time it takes to reach the maximum height, right? And the time it takes to reach the maximum height, we already know that is given as what? We already know that it was given. We already calculated that it is minus, right, mu, right, as minus mu sine 30 all over qa. See not? Yes, minus mu sine 30 all over qa. So when we plug it in, that becomes minus 2, right, mu sine 30 over qa. So when we have this here, we can plug it into this formula, right? We can plug it into this formula. Therefore, this is our T. So we have our range to be equal to, what's our U? Is 10, right? Yes, our U is 10. Or let me just write the expression as U cos theta is 30, right? Theta is 30 times our range now is minus 2 mu sine 30 over QE. So you just substitute and you get your answer. So we continue our substitution here. That is, our U is 10 raised to power 7, right? Cos 30 times minus 2, right? Times the mass of the electron, that is 9.11 times 10 raised to power minus 31, right? Times 10, that is U, so times sine 30 all over the charge of an electron is 1.6 times 10 raised to power minus 19 times the electric field intensity is 5,000. So when you evaluate everything here, you will have an answer. If you press your calculator, you can, if you have not written it, you can pause it. If you have evaluate everything here, we have an answer like 0.098 meter, right? That's the answer. Or in centimeter is 9.8 cm. Remember, we ignore the minus because the electric field is showing that the electric field is opposite to the distance where the electron is going to. Thank you very much. Until I see you next time, we are going to be solving the exercises involved in this chapter 2. God bless you.